You run your hand across your jaw and feel it. Stubble. It was not there yesterday. Now run that same hand along your shoulder, your back, your chest. Almost nothing. Somewhere in your body, a decision was made to shut hair growth down across nearly every square inch of skin you own, and then to switch it back on in one small patch on the front of your skull, and to do it only after you turned 13. That is not leftover fur. That is a message. For most of the last century, biologists called your species the naked ape. Desmond Morris made the phrase famous in his 1967 book of the same name, and it stuck because it feels true. Stand a human next to a chimpanzee, and the difference is obvious even from across a room. But it is wrong. You are not a naked ape. You are a shaved one. Count the hair follicles on a human body, and you get roughly 5 million. Count them on a chimpanzee of the same body size, and you get about the same number. The follicles never left.
Every one of them is still there, still alive, still cycling through growth and rest the way they did 2 million years ago. What changed was the instruction. Most of your follicles now produce what dermatologists call vellus hair. That just means the fine, short, nearly colorless fuzz covering your arms and your cheeks and your forehead right now. Hold your forearm up to a window and you will see it catch the light. Terminal hair is the other kind, the thick, pigmented kind, and it is what grows on your scalp, your eyebrows, your armpits, and, if you are male, your face. So the real question was never why humans lost their fur. The fur is still there. The question is why your body miniaturized nearly all of it and then chose to keep a few patches at full size. Why the face? To answer that, you have to know when the shrinking happened, and that turns out to be a question about skin color. Chimpanzee skin under all that hair is pale. It does not need protection because the hair does the protecting. The moment a primate's coat thins out, the naked skin underneath is exposed to African equatorial sun, and pale skin under that sun is a death sentence in slow motion. In 2004, geneticist Alan Rogers at the University of Utah worked backward from that logic. He and his colleagues examined MC1R, a gene involved in producing dark pigment, and found a variant that had swept through African populations and then stayed locked in place, unchanged for an enormous stretch of time. His estimate for when dark skin became essential was at least 1.2 million years ago, which means the fur was already thinning before that. Your ancestors were losing their coat before they left Africa, before they controlled fire reliably, before Homo sapiens existed at all. But why lose it? Nina Jablonski, an anthropologist at Penn State who has spent her career on the biology of human skin, argues the answer is cooling. Humans carry between 2 and 5 million eccrine sweat glands, a density no other primate comes close to. A chimpanzee overheats and has to stop. You overheat and you leak water across a bare surface, and the evaporation pulls heat straight out of your blood. That is not a small upgrade. That is the ability to keep walking through the hottest part of the day, when every predator with a fur coat is lying in shade waiting for dusk. Fur would have ruined it. Wet fur holds heat against the skin instead of releasing it. There is a second explanation, and it does not cancel the first. In 2003, evolutionary biologist Mark Pagel and geneticist Walter Bodmer published an argument in the Proceedings of the Royal Society that bare skin was defense against passengers. Fur is habitat. Lice, fleas, ticks, and mites live in it, and the diseases they carry killed early humans in numbers no fossil will ever record. Strip the habitat, and you strip the parasites. And here is the part of their argument that matters for your face. Once bare skin became the norm, it became readable. Skin shows you things for hides. Rashes, sores, scars, parasites, poor circulation, age. A naked human is a human whose health is on public display. And that turned skin into an advertisement. So your ancestors lost their fur to stay cool, to stay clean, and to be legible. Then, on one specific patch of that hard-won bare skin, they grew it back. Here is what makes the beard different from every other hair on your body. It does not appear at birth. It does not appear in childhood. It appears at puberty. And it appears in response to androgens, specifically dihydrotestosterone, which is testosterone converted into a more potent form. Women have the same follicles in the same places on the same jaw. They just do not get the hormonal signal that switches those follicles from vellus to terminal. A trait that shows up in only one sex, only at sexual maturity, and only under hormonal control has a name in biology. It is a secondary sexual characteristic. Same category as a lion's mane, a peacock's tail, a deer's antlers. Charles Darwin got there first. In The Descent of Man in 1871, he looked at the beard and concluded it was not built for warmth or protection, but for display, shaped by what he called sexual selection. The obvious guess is that beards exist because women preferred them, and for about 100 years, that was the assumption. Then people actually tested it, and the results were stranger than anyone expected. Barnaby Dixon, a behavioral scientist who has run more of these experiments than almost anyone, has spent years showing photographs of the same men, clean-shaven, with light stubble, with heavy stubble, and with full beards to raiders across multiple countries. In a 2012 study he ran with Paul Vasey, using participants in both New Zealand and Samoa, the pattern was consistent. Beards made men look significantly older. They made them look more aggressive. They pushed up ratings of social dominance and status. What they did not reliably do is win the attractiveness ratings. Across many of these studies, heavy stubble tends to beat the full beard on attractiveness alone. So who is the beard actually talking to? Increasingly, the evidence points at other men. A beard cannot be faked quickly. It takes weeks of visible growth. It requires a working endocrine system, and its thickness and pattern are set largely by genes and age. Across a campfire in bad light at 30 meters, it broadcasts one thing before you have said a word or thrown a punch. This individual is a mature adult male. That is exactly the kind of signal that matters in what biologists call intrasexual competition, which is simply males sizing up other males. And then there is the strangest hypothesis of all, and it is the twist in this story. In 2020, a team at the University of Utah, including Ethan Bezeris, Stephen Nalloway, and David Carrier, asked whether the beard is not just a signal, but armor. Their reasoning began from an uncomfortable observation. Human males are built for hitting. The proportions of the hand allow a fist. The jaw is one of the most commonly fractured bones in a fight, and the beard sits directly over the two most vulnerable points on the face, the chin and the sides of the jaw. They could not punch volunteers, so they built a stand-in. Sheepskin over a bone-like composite, mounted under a drop-weight rig that delivered a controlled impact. Some samples kept the full fleece, others were sheared, others were plucked bare. The samples with hair intact absorbed noticeably more impact energy before the material beneath them fractured, on the order of 16% more than the sheared samples. Sheep wool is not a human beard, and the researchers said so themselves. It is indirect evidence, and it remains genuinely debated. But it reframes the question in a way that is hard to unsee. Maybe the beard is not only a billboard. Maybe it is padding on the exact spot where a fist lands. Now hold all of that together and reconstruct a scene. It is dusk, somewhere in Eastern Africa, maybe 150,000 years ago. A small band is gathered near a fire. Your body has already been bare for 1,000,000 years, cooled by sweat instead of shade, sunburn held off by dark skin. Two men are standing slightly apart from the group. Nobody has raised a voice yet. They are reading each other. One is 19 and his jaw is smooth. The other is 31
and his face carries a decade of growth. Everything about the second man's status has already been transmitted, silently, in the 2 seconds it took to look at him. Age, hormone levels, survival long enough to accumulate that age.
There is no fight. There does not need to be. That is what a good signal does. It settles the question before anyone gets hurt. But signals have a weakness, and it is the same weakness that afflicts every fashion trend you have ever lived through. They lose value when everyone has them. In 2014, Zinnia Janif, Robert Brooks, and Barnaby Dixon tested this directly and published the result in Biology Letters. They showed rater sets of faces where the ratio of bearded to clean-shaven men was manipulated. When the set was full of beards, clean-shaven faces were rated more attractive. When the set was mostly clean-shaven, beards jumped in value. Rarity was doing the work, not the hair. Biologists call this negative frequency-dependent selection, which just means a trait is worth more the fewer individuals have it. There is even a historical shadow of this.
Nigel Barber went through more than a century of illustrations in the Illustrated London News from 1842 to 1971, tracking beards and mustaches, and found facial hair fashion rising and falling in step with the marriage market of the time. Beard trends do not oscillate because of celebrities. They oscillate because they are supposed to. And not every population got the same version of the signal. In 2013, Yana Kambarov and Pardis Sabeti led a study on a variant of a gene called EDAR, common across East Asia and among indigenous peoples of the Americas, which arose roughly 30,000 years ago. It changes hair thickness, sweat gland density, and tooth shape all at once, and populations carrying it tend to grow noticeably less facial and body hair. The beard your ancestors were handed depended on which corner of the world they were standing in. Which brings you back to your own bathroom. There is a good chance you deleted this signal this morning. You picked up a blade and removed, in 90 seconds, a display trait that took your lineage well over 1 million years to construct because a job interview or a partner or a habit told you the smooth version reads better right now. Given negative frequency-dependent selection, that instinct may be entirely correct. And there is one last cruelty in the system. The hormone that thickens the follicles on your jaw is dihydrotestosterone. The hormone that shrinks the follicles on your scalp, in men genetically susceptible to pattern baldness, is the same molecule. One chemical, 2 opposite instructions, depending on which part of your head the follicle happens to be sitting in. Your body is not growing you a beard and taking your hair. It is doing one thing, and the follicles are disagreeing about what it means. So run your hand across your jaw again. That stubble is not something your species forgot to get rid of. It is the opposite. Your ancestors spent 1 million years stripping their bodies bare so they could sweat and outrun and be seen clearly, and then rebuilt one thick patch on the front of the face on purpose, because being read correctly by other humans mattered enough to be worth the exception. You are not carrying leftover fur. You are carrying the only part your ancestors decided to keep.